Hello everyone. I made myself a little video here to explain about completing the square, which I think you might find interesting and its role in algebra. Let's take a look at now. Why is this thing important? Why learn it? What is completing the square? Completing the square is a technique that allows any quadratic equation to be written with a squared binomial. It's not normally used to solve quadratics, since any quadratic can be solved by a lot easier ways like factoring or using the quadratic formula, but it has other uses. So why do we complete the square? Well, it is used to prove the quadratic formula. You wouldn't have the quadratic formula without it. It also is a useful tool for graphing parabolas, and it can be used for finding the inverse of a quadratic function. Let's see how it's used. I want to complete the square here. I want to add a constant here that'll make this a perfect square, a binomial square that'll give me this. And the trick is simple. Take this number, the 6, divide it by 2 and square it. 6 divided by 2 is 3, square it, you get 9. That's a perfect square now, and it's equal to that. So it's a very simple technique. Let's try it again. What are we going to do? We take the negative 2 divided by 2 and square it, which is a 1. That thing is a perfect square now. It's x minus 1 squared. So it's an easy technique to learn. All right, now let's use the completing of the square to solve a quadratic equation. By the way, you would absolutely never do this type of problem this way, because there are much easier ways to solve this particular equation. You could just factor it, and it factors into, I believe, x minus 3 times x plus 2, which means your answers are 3 and 2. But let's try the technique on it. Now, the first thing we'd want to do is we want to complete the square. So we take the negative 1 divided by 2 and square it, you get a 1/4. Now, we're going to have to get that 1/4 out of here. So basically, I wrote negative 6 into a positive 1/4 minus 25 over 4, which is the same thing. Okay, I basically borrowed a 1/4 out of the negative 6. Now that gives me something where we can complete the square with. Now this whole thing here is a perfect square. So let's complete the square. And that kind of just leaves us with this guy, which I'm going to push over to the other side. And now I'm going to take the square root of both sides. Gives us this. And now let's write it in the form of x equals, and you get this. X is equal to 1/2 plus or minus 5/2. Well, 1/2 plus 5/2 is, well, 6/2, which is 3. And 1/2 minus 5/2 would be negative 4/2, would be the negative 2, which is the answers we thought it would be anyway. So yes, you wouldn't do it this way, but it does work, and it will work on much more complicated quadratics too. All right, now let's try and solve another quadratic. This time we're going to do one that's not factorable. In fact, the answers to this aren't even real numbers, but I think you'll find this one a little cleaner because there aren't any fractions involved. Okay, the first thing we got to do is set this thing up for completing the square. If you took the negative 2 divided by 1 and squared it, yeah, you get a 1. So we borrowed a 1 from the 9. Now we're set up to complete the square because this part here is a perfect square. Also, let's get the 9 on the other side. So we got negative 9 equals x minus 1 squared. Okay. Now the thing we want to do now is take the square root of both sides. Notice you're taking the square root of a negative number. That's okay. We all know how to do that. It involves the imaginary number I, right? So you get plus or minus 3i equals x minus 1. Add 1 to both sides. Your two answers are 1 plus or minus 3i. That was pretty simple, actually. And in fact, this is a good way to do it. although of course you could have used the quadratic formula also. Okay, now let's use the same technique to help us graph a quadratic. I think you'll find it's a very easy way to graph a quadratic, because the first thing you'd want to do on a quadratic is you want to know what the vertex is. So let's start completing the square on this. We're going to borrow a 9 from the 7, since that's what we need here. Negative 6 divided by 2 is 3. Square it, you get a 9. Now this part here is a perfect square. Let's complete the square. Now, the vertex of this is now kind of obvious. The smallest this part here can be is when x is 3, because that would make it 0. And if x is 3, y is negative 2. And that, yes, would be the vertex of your quadratic. The couple other things you'd have to do, find the x-intercepts and the y-intercepts. But other than that, this is probably the easiest way to find a vertex to a parabola. That's how that's done. Now, how do we find the inverse of a function? Let's complete the square on this one, which is, by the way, the same quadratic we had before. We get this again. Let's add 2 to both sides. Let's take square root of both sides. And let's reverse the x and the y. This function here is the inverse of this function. And that's a great way to do that, and that's probably the only way to do that. Okay, I'd like to show you probably the most important use of completing the square, and that's proving the quadratic formula. So let's take the normal standard form of the quadratic equation. We have ax squared plus bx plus c equals 0, where a, b, and c are any integers. And let's do two things right off the bat. I subtracted c from both sides, and then I divided everything by a. That's important because the leading coefficient always has to be 1 if you're going to complete the square. Now, how do we complete the square? We take b over a divided by 2 and square it. Well, b over a divided by 2 would be b over 2a. And that thing squared would be b squared over 4a squared. So let's add that to both sides. This is the constant we add to complete the square. This part over here is now a perfect square. So let's complete the square. Well, I did two things here. I completed the square on this side, and I multiplied the top and bottom by 4a. Why did I do that? Well, I wanted the two denominators to be the same so I could add these two. That would make sense, right? Okay, let's go to the next page. Okay, let's finish up here now. The next thing I want to do here, as I get my laser pointer back there, is I want to add these two things together. They have the same denominator, so they should be easy to add. And notice I took the negative 4ca and wrote negative 4ac. I put it in the back. Kind of looks more like the actual quadratic formula now. Now I'm going to take the square root of both sides. Notice at the bottom here, 4a squared became 2a because you took the square root. I left the radical sign on the top and we made it plus or minus. Now let's take this guy and subtract him from both sides. Perfect. Notice that the denominators are the same, so we can add them. And there is your quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that can be used on any quadratic equation and get the answer. Okay. Let me know if you have any comments in the comment section.